Assalamualaikum, Professor Luqman. Our group is given a task titled Production of High Fructose Corn Syrup via Glucose Isomerization. So my name is Fardina Faisal. My metric number is 190071. I will be explaining the introduction of this process. Firstly, high fructose corn syrup is a fructose glucose liquid sweetener alternative to sucrose used in many foods and beverages. And as known, HFCS is made by the chemical and enzymatic hydrolysis of cornstarch containing amylose and amylopectin to corn syrup, containing mostly glucose followed by the isomerization of the glucose in corn syrup to fructose to yield HFCS. And there are three categories of HFCS in common use. When there is 90% fructose and 10% glucose, the HFCS is called HFCS 90, which is used in specialty applications. But it is more important when the HFCS is blended with glucose syrup to yield 42% fructose and 58% glucose to yield HFCS 42. And also, when there's 50% fructose and 45% glucose, the HFCS is called HFCS 55. And there is absolutely no association between HFCS use and worldwide obesity because HFCS is really a minor sweetener in the global perspective.
Okay, my name is Intan Nur Anissa binti Muhammad Zalani. My metric number is 187412. So I will be explaining the process flow diagram for the production of high fructose corn syrup via glucose isomerization. So as you can see from this PFD, corn is inserted into the milling. Okay, the milling type we use here is wet milling. The reason why we use wet milling is because it is more versatile and can produce higher yield than dry milling. Okay, the purpose of wet milling is to separate the corn kernel from its constituent, which is germ, hull, starch, and gluten. So because we want the starch, so that's why we have to mill first, and then it goes to the liquefaction process. In this liquefaction process, an enzyme is added, which is alpha amylase enzyme. The purpose to be adding the enzyme is to break down the starch into glucose. Temperature in the liquefaction process is at 100 degrees Celsius to ensure the starch is heat evenly. Next, we move on to the saccharification tank. In this saccharification tank, another type of enzyme is added, which is glucoamylase enzyme. This is to further hydrolyze the syrup into 96% dextrose syrup. Okay, the temperature is cooled to 60 degrees Celsius. Saccharification process influences the flavor of the corn syrup produced. The syrup is then filtered and decolorized using granular carbon. This is the filter. Filtered and decolorized using granular carbon column to obtain clear syrup. The function of granular carbon is to remove color, odor, and flavor. Next, it moves to the isomerization tank. The clear syrup from that we already filtered move into the isomerization tank that is containing immobilized glucose isomerase to obtain 42% fructose, 50% glucose, and 8% other saccharides carried out at 60 degrees Celsius. The function of glucose isomerase is to convert glucose into fructose. Next, the last step is evaporation. This process continued from the isomerization process. to increase the concentration of the dextrose by removing water present in the syrup. This process usually requires 3 stages of evaporating process. So after evaporation ended, the syrup will be transferred into the storage tank.
So for the type of reactor used in the high fructose corn syrup production is packet bag reactors, as they are commonly used at industrial scale because they cause lesser damage to the enzyme catalyst. There also is retention within the reactor. Temperature profiles and uneven packing of the catalyst can adversely affect packet bag reactor operation and have to be considered for practical purposes. The kinetics of the enzyme reaction also influences the choice of reactor configuration. Packet bag reactor predicting better results than stirred tank for a reversible catalyst maintains type kinetics. So there's a few relevant information to be considered for the reactor design. First, the type of enzyme and substrate to be used. Next, operating conditions. Next, kinetic model for enzyme reaction. The fourth one is enzyme decay rate, and then incidence of diffusional restriction, and the last one would be mode of reactor operations. As for the catalysts used in the HFCS production, the first one is alpha amylase, which is produced from Bacillus species. They hydrolyze cornstarch to short chain dextrin and oligosaccharides. The next one is glucoamylase, which can be also called as amyloglucosidase. They are produced from fungi such as Aspergillus. They break dextrins and oligosaccharides to the simple sugar. And the last one of the enzyme or catalyst is glucose isomerase. They are also called D-glucose ketoisomerase or D-xylose ketoisomerase. They convert glucose to fructose. So that's all from me. Thank you.
My name is Umi Fatiha binti Mawalafi. My metric number is 190066. I will proceed with the market info. Okay, so the demand of HFCS start to increase because of the periodic upset in the supply of sugar at the mid to late 20th century. And the net cost production of HFCS is considerably less than domestic cane or wheat sugar. So the price of the HFCS is slightly lower than the sugar. At the period of 1975 to 1977, the HFCS price of dry basis is 71% of sugar price, and it's dropped to 57% during 1978. For the application, the HFCS is firstly used in pharmaceutical application as crystalline fructose. And HFCS is highly used in food and beverage industry due to its unique sweetness and physical and functional properties. It is also used in processed bakery and cereal products, and it is used in dairy application for its fermentable sugar such as yogurt. So that's all from our group. Thank you.